Hello everyone. Today we are going to do Leetcode daily challenge must sorted array. So basically in this question we are given with two arrays and both of them are sorted. And as they are sorted and we are required to merge them. So now the thing is that as both of them are sorted, so we need to compare both of them. We need to think in such a manner that we could utilize that sorting thing. So that's the thing which we need to do in this question, and how we need to utilize. For that only we need to come up with a solution. Now here, now we can see the constraints. The constraints here are nums1 dot length equals to m plus n, nums2 length equals to n. Basically, from these constraints only we got the hint that how we can do this question. Means in this nums1 dot length could, as these are arrays, right? So because of the arrays only we would be having predefined length of the array. So here only they have given us that the length could go up till m plus n. Not only this m but m plus n. And nums2 length is n, and here m and n, both of them won't exceed 200. And basically individually they won't exceed 200, and also if we sum up them, then also they won't exceed 200. And the elements which are being present there are 10 raised to power 9, means the maximum element which could get into the array at any index could be 10 raised to power 9. But the thing is, yeah, we are required to keep a set so that we could use that type of data type only. But as it is already int in nature, so our answer would also be int in nature, because we are merging it, not doing anything else for time being, means not adding or something like that. So the follow-up is that we need to come up with a solution that runs in order of m plus n time. Yeah, so I'll show you that solution only. But now comes the part that what proof force comes in our mind for doing this particular question. So now, because the arrays are already sorted, right? So if arrays are already sorted in nature, so what we can do is we can use auxiliary space, right? We could use auxiliary space, and then what we are required to do, we need to simply compare both of the elements, right? Whichever would be smaller, we'll push that into our auxiliary space and then move that particular pointer only. Means if this we have used, then we will move this only. We will keep it as it is. Then it will come to 2. 2 and 2 would be compared. Both are saying either when we can move, we then just move this one only. Then we'll again compare. Then 2 is smaller, so we'll move this one. It comes to 5. Then 3 and 5 compare 3. So basically if we do all this, yeah, here time complexity would be already m plus n only, but the space complexity would also be order of m plus n, right? So for avoiding this particular thing, what we can do is we could, rather than using any extra space, we could manipulate this nums1 array itself. So when we will be manipulating this nums1 array, then we would come up with a solution in which nums1 is equals to m plus n length, the way it was given in the constraint, because that constraint was itself a hint that we can use this nums1 array for giving our final answer. So after that, we could directly come up with a solution where space complexity would be only of order of n. Like that only we could come up, and now we need to think that how we can do that. So for doing that, we are required to directly check for the indices, right? The way we were checking our indices here we were doing from the starting, but when we would be using nums1 array as it is, then we are obliged to start from the last. That is the thing, because the thing is that this particular array would be filled up and this one will also be filled up. But if we do m plus n, right? If we make our nums1 till m plus n, then we could start filling last n positions, with whatsoever is greater than, right? So we would, and also we are in this sense, so we are required to start from the last one so that we could fill up all the n spaces which are being there in this m plus 1 array. Until then, we would be able to sort our n elements, but now we are left with m elements from both of the arrays, basically combining both of the arrays. So in that sense, we will be able to sort all other elements also on that basis only. So as we would be starting from last, right? So in that sense, what we are required to check is, we are required to check which is the greater element rather than the smaller element. Because now we would be doing everything in descending order, because from the last towards the first. So that's, if we were checking from the starting, means if we were checking from here, then we would have done in ascending order itself only. But now as we are going from back to front, we are required to do in descending order. So these were the two solutions. Means I've just explained you overview sort of. Let us do some test cases with the same. Then we'll come up with the codings of the same. Now here the first test case, that when we are given with this particular 1, 2, 4, 5, right, all the smaller elements and the nums 2 are is here, but just one element is there which is somehow could come here. So our final should be something like this. So my algorithm here is something like that. M and n which are there, basically m is length of nums 1 and n is length of nums 2. So what I would be doing is, I would be simply take a variable t, and in this t variable it would be something like m plus n minus 1, which would be 6, right? And I will start with iterator I and j, and I would be 3, means basically m minus 1, and j would be n minus 1, so that is, it would be 2. So what I would be doing is, I'll start with nums of I'll basically start with nums of t minus 1, or not t minus 1, basically t. So I'll start, because I have already taken it as t minus 1 only, so that's why. So I'll start from nums of t, and I'll assign either of them on the basis of, that if nums of 1 of I is greater than nums of j, nums 2 of j, right, then I'll assign here nums of 1 of I and decrement my I, and here also I'll decrement my t side by side only, and this is nums of 1, the original nums 1 array. So like this I would be doing, and if this is not the condition, then I'll do nums of 1 t minus minus equals to nums of 1 j minus minus. So like this only I will be filling up the array. So here we can see that our pointer is at this 7 position and 5 position. We are checking both of these things. Now we'll check that who is greater. Now 7 is greater, right? So we have filled 7 and moved our pointer towards the 6. Now we'll check 6 and 5, which one is greater. So 6 is greater, right? So we have filled here and moved that pointer towards right. And then we'll again check who is greater, because it has been moved. So 3 and 5 were a pair, so 5 is greater, so we have put 5 here. And then we'll compare 4 and 3. So 4 is greater, so now we are moving this above 1 nums 1. So like this only we would be moving, and we'll fill up our array. But there would be a condition when this particular nums 2 would have been completely filled. So in that scenario, our nums 2 ends here only, and then we are left with this nums 1 array only. Then what we are doing, then we are comparing the nums 1 array only. So according to this example, we can infer that first thing is we need to move only that pointer from which we have chosen the element, and the second thing is we need to keep check for left elements, left out elements. Basically when one array finishes. So these 2 points we can check from this particular example. Now let us see for our second example. So in our second example, here the thing is that we are given with 1, 2, 7, right? We are given with this 1, 2, 7 and then 3, 4, 5, 6, 8. So here now the thing is, earlier we were having nums1 which was greater than nums2, but here we are having nums1 smaller than nums2. So for this case only I have taken this example. So again it would be similar to that only, but the thing is that I already told that now we would be filling n elements, not n elements, basically m elements would be filled. It would be confusing then, better I should say that now we would be filling those n elements which are there. Basically n spaces would be filled and first 3 spaces would be as it is. So here n spaces would be filled. That is the thing we would be doing and comparing. So we'll compare 7 and 8, and 8 is bigger, so we'll move ahead in nums2. Then 6 and 7, 7 is bigger, so we'll move ahead in nums1. So 7 is now here. Then 2 would be next element. Then 2 and 6 I compare, 6 is bigger, so 6 is, then all the elements will be moving right till nums2 ends. And then we are left with this nums1 array only, where only 2 elements are left, that is 1 and 2. And thus we would be filling that particular element into our nums1 as it is. So this is how it would be filled when the nums1 is smaller. And now comes the last part, when there are duplicate elements and also the nums1 is having all the elements which are greater than nums2. So in that scenario, again the last 2 elements, if there are any greater one, they would be filled up here, and then all the elements which are there which are greater than nums1, those will be filled up, and then the smaller elements would fill up. So like this only we would be able to fill up our nums1. We would be able to fill up with our nums1. So next part is about the coding, how we are required to code this solution. So from those examples we can see that how we can code them. So the part is I, j and t. These are the variables which we were taking, and we need to keep a check when both of the arrays are present. So if whosoever is greater than, we are required to decrement and assign that to t's position and decrement that only, else we need to decrement I. The thing which we were doing in first example, when whosoever is bigger, we were taking that particular, and then if either of those arrays are still left, right? So in that scenario, we will individually assign the elements. So like this, we would be able to fill our nums1 array and return the merge sorted array. So here the time complexity would be simply order of n plus n, and the space complexity would be order of 1, because we are not using any auxiliary space here. So this was all for this particular solution. If you have any doubt, you could comment that down. Thank you.